Now, let me start the new topic. That's the one main topic is called hash. And I told you guys already, the newer technology like the blockchain, all the things won't be possible without hash. So just keep thinking in mind. Again, this class is not about blockchain, but keep this point in mind. Whenever you learn or you might know blockchain, this is the core concept going to help you a lot. Okay. So what is hashing? It's very, very interesting concept. Okay. If you talk about encryption, okay, encryption is a two-way. Your plain text can be converted into cipher. It's like encrypted data. Cipher can be converted to plain text. So this can be converted this, and from this data you can get your data back. This go two-way. But in hashing, if you have any data, let's say plain data, if you convert the data in some form, like here with cipher, let's say convert into some new data here. Okay, here we use encryption, but instead of encryption, if you use hashing here, okay, from plain data, if you convert it into new data, okay, with the help of hashing concept, okay, there's no way available, or it is impossible, I can say, okay, impossible, I can say, to get your actual data back. Okay, nobody can give you actual data, even though you yourself convert your data to your different formats called new data. Mostly this data is called hash data or hash value. So convert a plain text into hash value with the help of concept called hashing. That's what the topic we are going to discuss. Okay, there's no way, it is impossible. I'll tell you why impossible. Okay, to get your data back. And that is it's called one way. Only we can convert data only one way. We don't have a way to get the data back. If you plain data text data lose from this data, it is impossible to get the data back. Why impossible? I'll tell you in very detail. But what are the use of the hashing? That's also I will tell you in very detail. Okay, but before this, let me take one more example, and that example might help you to understand the remaining part of the hashing. Okay, so to give this example, right, because this is a good example to understand the one of the right and good use case of the hashing. Okay, let's say me and you would like to play a game. Okay, and let me set the rule for the game. Here, my name is Vimal. I would like to play a game with you. Let me picking some name from here. Let's say we have maybe some Tom over here who is there in this meeting to play a game. So these are two participants. They would like to play the game. Okay, in this game, the rule is, okay, one person will tell one random number, let's say 10. Second person also will tell one random number, let's say 20. Okay, and both the number we will sum 10 plus 20, and sum will be always at 30 here. If the sum of this number, if it is even, then Vimal will win. The Vimal would be the winner. If sum of this number is odd, then Tom will win. Tom will be winner. So this is the rule we have created. Okay, a rule we have created. So this is the game. That's all. In this game, you know what, guys? In this game, okay, whoever speak last always win. The drawback of this game is, okay, whoever speak last, they win. This is the drawback right now according to this rule. For example, okay, let's say Vimal may be a little bit intelligent and Vimal want to win always. So they always give this chance to Tom and say, Tom, do one thing. You speak your number first. And I said, it's T and this is V for Vimal. Let's Tom speak, let's say number 13. Vimal know when even number come up, total sum, then I will win. So Vimal might say, let's say 3. Sum of what we 13 plus 3 is 16. 16 is even we will win. Again, Tom will start first and say Tom say let's say 10. Then we will say 2. Where 10 plus 2 is what? 12. 12 is even, we will win. Again, let's say take the random number 55, let's say is odd. We will know odd. If I add with odd, 56 come up. Again, we will win. So in this game, whoever speak last or give the input last, they win. Okay, so it's like a game is good. Who will win, whoever, even or odd. But in this game, the only challenge is, okay, who understand this? The loophole of this game, the loophole is whoever speak last, they win. Because they know the rule, even and odd. Okay, win. To solve this issue, this loophole. Okay, and even though guys, there's one more rule also. Okay, whichever the number last person want to speak. Okay, because the last person, this means maybe some number I have in my mind, Vimal has in mind, right? I can't speak out because I'm the last person. First, let's say in this game, Tom is always want to speak. Okay. And then say last person, Vimal will tell their respective numbers. Okay, because Vimal last. So whatever Vimal have in the mind, maybe that point in time initially, Vimal might change their mind. Okay. In this game, why I am winning? Why the last person is winning? Because last person is doing some small kind of trick here, or small kind of cheat here, or small kind of trick here. Okay, what trick they're doing? That's what I'm trying to explain here is. You say, I know if a first person, there's a first person. If they say odd number, I also say odd number. Even is which for me is winning. I change it. If somebody say positive number, or sorry, not even number, not positive, even number. I also use even number. I will win. Okay, so last person is doing some trick. Okay, how can we solve this challenge? Okay, how first person come to know what was last number you're talking about? You're not doing any trick. So how can you, I think you understand what I'm talking about. Okay, how we can solve the challenge that last person is trying to speak last, and they are not manipulating, they're not changing the number. Okay, after listening the number from the first, right? They are not doing any trick. Okay, how can we solve this challenge? Okay, like this challenge in this particular game, okay, can be solved very, very powerfully with the concept called hashing, or hashing techniques, or hashing concept I'm going to explain you. Okay, I think you understand the game. Yeah, I think you also understand the challenge in this game, that last person doing some trick, and this last person is always winning. Okay, winning because he's doing trick. Okay, trick means they're changing the number on the fly by listening from the first. Okay, so to solve this challenge, guys, we have to understand the hashing. By applying hashing, this concept, this problem can be solved, and the same idea can be used almost in all the areas in this world. I'll tell you multiple examples, you get the idea where it can be useful. So keep this screen as it is. I'll come back to the screen again one more time. But before this, I will just first explain you the concept called hashing. Okay. Now, guys, this concept, this challenge I explained to you about this game. Okay. Now, let's first understand what is hash or hashing concept. Okay, hashing concept. So hashing say, if you have any data or plain text, you convert your data into one form. That form is called hash value. Okay, sometimes it's also known as hash code, sometimes known as hash value, sometimes also known as a message digest. Multiple name they have, whatever name you want to use, you can use same thing. Okay, but it is one side only. Okay, from this message digest or hash code, you can't get your data back. This is the rule, one rule of the hashing function. That is the reason they are known as one-way hash. Why is impossible to go one way? Okay, it is something like this. Let me take the example to understand this. Let's say we have a requirement. Okay, I will have to store the password of the user. Okay, somewhere in my database, somewhere in the database. My password, let's say Vimal is a user, and the password of this user is, let's say, Red Hat. So this is the username and this is the password. I'm storing in some file, some database. So maybe we have one user called adding the password, maybe 1, 2, 3, 4, 5. If you're storing the password in this way, your password is the most sensitive thing. Okay, anybody somehow try to break your system can get the text password. Okay, if you store the password in the clear text, they can easily break. To make this thing secure, you guys may be more intelligent in terms of security or security guys. You suggest rather than you store your password of all the users, right, in the clear text, do one thing, all this password you can lock with the key, symmetric key. Means encrypt this. Okay, so this password, let's say this password Red Hat can be encrypted and into cipher. And the cipher text we can store here. It makes the thing secure, no doubt, no challenge, right? But the challenge here is, right, we have thousands of passwords, multiple different accounts, maybe the banks, for example, right? Every password is encrypted with some kind of key. But what if somebody break the key? Okay, somebody break the key. Okay, if somehow somebody get the key, your main key or master key, what I already told you in my last class, by having the master key, they can unlock and decrypt all the password, because the chances we have is, if you know the key, you can decrypt, right? There's two ways. We can lock also, we can unlock also. There's a possibility. Okay, if you break the key. Yeah, we can't do brute force. You know, maybe keys can by AES format. We can't use brute force to break the key, but somehow if somebody stolen your key, the way you can see visible here, somehow anyhow, if they stolen the key, they can break it. So storing some sensitive data, okay, like password, especially into the cipher text, most of the cases might not be good choice. Okay, so what can we do? Okay, we can rather than we store the password in this clear text or in the cipher text, means encrypted way, if we can store the hashing values here or hash values here, okay, we can use the hash algorithm and store the ARIC password in the hash value. Okay, the good thing about hash value is it is impossible to go back or impossible to break. You can think in this way. Okay, why is impossible? Is it depend upon the hashing algorithm. For example, if your password is Red Hat or data is Red Hat, and if you want to convert this data into hash, okay, there's different kind of hashing concepts or algorithms or the functions available for hash functions. One of the simplest hash function to understand this concept is a count hash function. So count is a one very simple, sophisticated hash function we have. What count function will do? Okay, instead of what count function will do, if we give Red Hat as a data to the count function will count it. How many characters we have? REDSAT 6. So they will convert into 6. Okay, so Red Hat here is the plain text or my message. I can say this is called message in this word, or you can use the word plain text. Converted into this value. This is called hash value or message digest. Okay, of this message digest or hash code. Okay, now you guys may understand why. I think might understand why hash is one way. From Red Hat, we can get the number. From this number, it is impossible to get your data back. It is impossible. How can you get Red Hat from 6? Okay, how can you get it? Okay, because from the 6, it means 6 means 6 count. Red Hat is not the only character or word that has 6 count. Okay, it may be, for example, have maybe digest also have a 6, right? Cipher also have a 6. Okay, some other number, maybe my or hello 1 is also have 6. A number character. Okay, converting data back in this example is impossible. I think you understood. From 6, you can't get the data back. Okay, this is one of the simplest hashing algorithm, is called count algorithm. Okay, this will have a lot of bugs, not bugs, I can say a lot of challenges we have. I'll tell you in a minute. Okay, then we go for the more sophisticated hash functions. Okay, but this is the example that I'm trying to explain you that it is one way. Why is one way? I believe understood. Okay, understood. So it means now if you want to store somebody password, let's say I have one user called Tom, and Tom want to store the password. Okay, so what can we do? Okay, what can we do? Now, if you think about password perspective, password is one thing that typically belongs to per user, right? Per user. Okay, but password is one thing that is stored in server database. Okay, for example, right now it is Gmail. Okay, Gmail. My password I created as a Vimal. Okay, the password, you have only two locations. Either I have in my mind one password stored in my mind, my own password stored in the Gmail server database. It means somebody at a Gmail side, if they go and see their database, they can find my password. Okay, if I store in clear text, they can see it clearly. But even though if I don't store in clear text, if I encrypt it, because the key belongs to Gmail only, this company had their own private key, so they can go use that key to decrypt my password, or they can see my password, right? Okay, so in this case, in this example I'm talking about, either store clear text, either store my password encrypted text. In both the way, finally my password is going to store in their hard disk, and they are the one who are encrypting, decrypting by their key. Okay, so they can also decrypt my password, right? But if you want to set up a scenario such a way that password only stored in the user's mind, okay, for example, you create one website or application. Let's say in this example I'm talking about Gmail again. Okay, and this is Gmail hard disk where the password is stored about the user and their password. Okay, and this is the actual user called Vimal. Okay, and this is the user, that's a human being, and Vimal want to set the Gmail password, and Vimal want this password stored in the Vimal minds only. Okay, so let's say Vimal in the mind, they say my password is Red Hat. Vimal plan to use this password. Okay, and this password somehow by the application stored in the hard disk of the Gmail, and they say Vimal password is Red Hat. In this case, anybody can break either in the clear text or in the encrypted way, because encryption key they have their own. They are the one their hard disk belongs to. They can decrypt. So instead of password stored in this way, okay, the right way to store the password, okay, is a technique called hashing. Okay, with the help of this hashing technique, okay, when Vimal want to set the password, okay, this password, my program, okay, my program will give this password to my count function. Count function give me final output 1 2 3 6, and 6 we will store here. Okay, so finally in the Gmail hard disk, my username Vimal store and my password stored in this way as 6. Okay, now what benefit of this? Somehow anybody who got the access of this file, maybe somebody read this file, okay, or maybe this file may be encrypted data, okay, they get the private key or maybe any kind of secret key, maybe, okay, but looking at this number, nobody can get my actual password. Okay, actual password is only there, even though this password is stored on the Gmail hard disk of the Gmail application, but password is only stored in the Vimal's mind. Okay, so how next time Vimal can log in? So next time when Vimal will see this page for login, okay, and now I'm going to give my password here, let's say Red Hat. Okay, who knows my password? Only my mind know. Does Google know my password? Even though I'm going to access Google account, but Google is not knowing my password, because in the Google hard disk, my password is not stored, my hash value is stored. So if they store my hash value, from this hash value, can they get my real password? Impossible. See, from 6, how can they get my real password? Nobody can get it. So how they can authenticate me? How they authenticate me? Okay. So when I click next to login, okay, this data go to Gmail. Gmail receive this data, let's say password Red Hat. At this time when I log in, okay, and Gmail know behind the same password stored in the hash format, This data, they again give input in the same hashing algorithm. Okay. And good thing, one more guys, property of hash algorithm is, okay, if you create a hash of Red Hat, they give 6. Next time again, if you give the same value, they give the same value. Okay, this is also one of the property of the hash. Okay, every time you give same value, the output is always same. In encryption, guys, it's very different. Okay, in encryption, there's some concept called salt random, but I thought we might discuss today. Okay, they may be different. Okay, but hashing, one of the property is, okay, if you give some value, same string, the same hashing algorithm, count for example, they always give the same value. So Gmail, after receiving the Red Hat password from the Vimal, because Vimal might only know the password, Gmail uses the same hash algorithm called count, and the output of this Red Hat, when they input password, they give inside the count function, their answer is gonna come 6. Now this answer, this Gmail find on this runtime, and this answer they will now go to their hard disk and they compare it, equality. Okay, and they check if this password that is stored in my hard disk is equals to what I calculated at this point in time. If they're equal, this means user are authenticated. It means this guy know the real password. This guy know the real password. It means they are authenticated. Okay, if they're authenticated, I give my access to my account. For example, in this case, my partner give wrong password, so they give wrong password. They're authenticated. Okay, so mostly guys in the password world, especially, this is one example talking about. Another example we'll see about more about hashing. What is the other use of hashing? Okay, so one of the use of hashing algorithm, what I was trying to tell you there also, one of the use of the hashing, this hashing is for authentication. So most of the areas, especially in the password world, especially, we use hashing for authentication purpose. Okay, almost we go to databases or we go to Linux servers. Okay, everybody, they store the password into the hash format. Okay, but in this example, okay, in this example, what example I show you right now, where my example is. So in this example, okay, this algorithm doesn't looks good. There's a lot of limitations, or not limitations, there's a lot of challenges in the algorithm. In this, by chance, in this example, if somebody try to log in with a different password in the email account, okay, let's say maybe somebody tried to give maybe data called as a screen. Okay, if they try to log in with this password, again this password go to Gmail, they give here, take the input as a screen as a data, again put the count function again count 6 come up, this 6 equals to the 6 stored in my hard disk, my real password, yes, now get authenticated. So count function has an issue. Okay, if some more similar data come up same length, both the hash value 6. Okay, in this case, you will face this kind of issues. What issues you will face? Maybe Vimal set the password Red Hat, but somebody can log in Vimal account with the other password, because they're using count function, and count function give same value from different data. And this concept is called collision. So in count function, we have issue of collision. Collision means, okay, Reddit also give the same hash value, screen also give the same hash value, maybe shared also give the same value 6. Hundreds of thousands of strings we have, they give the same value. So in the count function, we have the collision issue. So any hash function, okay, the good hash function is it is always one way. That is a one key thing of a hash function or hash algorithm, I can say. Okay, any algorithm is the best algorithm that is always one way. Count is also one way. Nobody can break this count of Red Hat 6. From the 6, we can't get the Red Hat back. So count is again the ultimate one-way hash function. Okay, but this is one of the property of the hash function or hash concept. The second property of hash function is, okay, your hash function should be collision resistant. Okay, means no two value can give the same answer. or no two string should give the same hash values. Okay, but in count we have this issue, or because we have this issue, then in this example of authentication, Vimal might set the password red hat, but somebody will log into Vimal account with the other string. Okay, because they give the same value. This is called collision. Okay, but we have to use collision free. This is called collision resistance. Should be collision resistance. Okay, so we can try with other hash algorithm. Let's say there's one more famous hash algorithm for learning purpose. It's called mode hash algorithm. Mode is called modulus. What is modulus? You guys know. For example, if I say 13, and if I take the modulus of 13 with 10, 10 means if you divide 13, okay, with 10, 10, 1, 10, 1 to 1 is 10, and then 3 is a reminder. So 3 is a reminder, and this reminder is called modulus. Okay, modulus of 14 from 10 is 4. Modulus of 17 from 10 is 7. Okay, so let's say 13 in my password, they're coming up. So rather than store the real rate 13, okay, we can give the 13 to the modulus function. And they give the answer 10. And modulus my base would be 10. Means I would divide by 10. 3 come up. From 3, it is possible to convert 13? Impossible. So modulus also, guys, right? Because from 3 is 1, we can't we can find 13, right? Because maybe modulus 23 or so. So how can you find 3 is 13 or 3 is 23? We can't find, right? So modulus also one of the hash algorithm used in some area, no doubt. But again, the challenge in the modulus is, good thing is one way, but again, challenge in the modulus is there's a lots of data or the messages, they can get same hash values, so same modulus values for message digest. Okay, so again, mode is not the great hash algorithm. So finally, guys, property is what I'm trying to tell you. Any hash function, the property is one way, collision resistance, and third is if you give the same message, that is called same text, the same algorithm, you should get the same final hash value. Otherwise, they will fail. So the count red hat gives 6 always same. So if you have 3 properties, then you have the best hash algorithm. These 2 properties must. Every hash algorithm should have must. Okay. Only the game is which hash algorithm is more collision resistance. That is the that algorithm is a winner in this game. Okay. So as we go in this journey here more and more, a lot of things has been done, a lot of things has been tested. We start with count hash algorithm, we start with mode hash algorithm, right? Everybody has the collision resistance. I to explain to you, 2 values give the same value, so 2 messages can give the same output. Okay, then we move to some more sophisticated, powerful algorithm in the market, and has been called MD. It's called message digest. We have multi-version MD 0, MD1, MD2, MD3, MD4, MD5, MD6. One of the well-known algorithm market for MD5. Okay, and they say the guarantee is if you use MD5 as an algorithm name, is one of the algorithm of hashing, same way we have in mode or count. Okay, they say we are collision resistance free. Okay, we are collision resistant means we have no collision. Okay, if you give data Vimal, I give some hash values. Okay, any other string that you find, okay, you won't able to find the same hash values. Okay, that what mode, so not mode, MD, message digest 5 algorithm is a one algorithm, well-known algorithm you guys might have heard about. Okay, let me open and show you. Okay, so MD5 is a algorithm. Okay, a message digest algorithm. This is what MD524 over 6 we have Wikipedia. Okay, and this algorithm, guys, is giving you 128-bit hash value. Okay, the final value is also fixed, 128-bit size hash value they give you. Okay, they will give you finalis. Okay, for example, if I want to show you how to use MD5, we can have a lot of tool available in market, but let me use a tool called OpenSSL. In OpenSSL, okay, if you see the help of OpenSSL, you will find in the message digest means that is called message digest concept name. That's called hashing. Hashing, something also known as message digest. We have multiple algorithms. We have one is MD5. Okay, so if you use MD5 here, okay, and let's say if you type Vimal, enter, and control Vimal, enter, and control D or control C, this is what the value come up. Or maybe maybe let me write in other way. What the syntax would be maybe we can syntax maybe MD5, or I think the syntax maybe is MD5. Let me check the help. That makes more sense, right? So in the help, we can use this option. There's even the multiple other options also we have. We can use MD5 some function also that we have, but here they take as input binary match. They don't have that. I think they're taking from some file. I think from file. Actually, this is what they're talking about. So let me create one very quick file. Notepad my dot data or txt, and let's say I have the password for Red Hat, for example. Save. Okay, now I can use this command to hash it. So this is the output of hash command. This is a 120 bit hash value gonna come up. What MD5 is claiming, okay, that any other data you put or any other value you change in this file, whatever you try, okay, even though you give extra space also, extra space anywhere, the entire hash value will change. Sorry, come on, the last command was this one. It changed. Even for example, let me show you one more time. We change this one space also, this value changed. See here, this entirely changed. So they claim that if you want to try, if you just trying to look for two values that give the same hash, it won't possible. Okay, it won't possible to find two values with the same hash value, two different strings or two different data with the same hash value. So there will be no collision. But technically, logically possible, because they're giving only 128 bit hash. So there's thousands of value may be possible that give same value, but it is very harder. It is very harder. Okay, but MD5 is very powerful, but because of the computing power increase, we have a now lot of powerful computer in the cloud, a lot of CPU and GPU available with powerful performance. Okay, now we can find two different values or two different text. They can give the same hash values. Okay, then you will be in the same problem what I was talking about. Okay, what I was talking about, if Vimal is storing the password in the count algorithm 6 here, and somebody type a screen, they also get the same 6. So same hash value come up with two different string. It's either type password Red Hat or type a screen, both will log in. This kind of issue will face. Okay, if you have the same hash value. So MD5 was claiming that no two messages or two different texts you can find with the same values. But because of the computing power increase long back, okay, by the power computing, we can find two different values or multiple two different values that can give a same hash. Okay, and that's what guys that are also talking about. Long back, some kind of attacks happen, and this kind of break is possible in this much time, because a lot of combinations we have to try. This much time, this much CPU operation you have to perform, depending on computing speed or the CPU speed. So if you're very powerful, maybe in some days or in some minutes, this can be bricked. Okay, so there's no bug in the MD5 as such. Okay, bug, but the way it's been created, this much time require of a CPU. Okay, depending on the CPU speed. Okay, maybe one CPU might run millions of operations in 1 second. So that's much divide time you can take to understand, to break the thing, to find two different hash value of the same, two different text that give you the same hash value. And that is very dangerous things right now, maybe not for our data, but let's say this is banking data, some most critical data. We can't, military data or national security data, we can't take this risk. Okay, so that's what guys the MD5 was. Lot of new changes we have done in MD5, and then we launched MD5 and that is a more powerful than MD5. Okay, but rather than we nowadays, because this was the challenge we had in 2013 a lot after this break. So now lots of authentication algorithm move from MD5 to the different algorithm that is so powerful. Okay, and name of that algorithm is called SHA, SHA algorithms. So we move to the SHA algorithm. Again, this is the message digest algorithm or the hashing algorithm. We move to the SHA algorithms. Okay, so again, they have multiple versions of the SHA. Again, this is the message digest algorithm. Okay, they use bigger key, 160 byte. There was 128 MD5. This is 160-bit key they use. Okay, so again, same file, guys. If you want to hash with SHA, you can hash with SHA-1 algorithm. But again, SHA-1 algorithm has some kind of bug. We have a better improved version of SHA-1 that has also been attacked in 2011. These many operations, even though this big operation actually technically not a small one, we can use to do this collision. Okay, so we move to SHA version 2, and that is one of the most usable version we have. Okay, in SHA version again we have multiple different size of not keys, guys. Here there is no concept of key. Okay, a lot of guys is confused. They use this word that we use MD5 SHA for encryption, right? Message digest, guys, or hashing algorithm is not encryption. It's a different concept. Encryption, different concept. Okay, and MD5 or SHA, these algorithm is an algorithm for hashing. They don't use for encryption. A lot of guys use this term. I want to encrypt with MD5 or SHA. No, they are not encryption algorithm. Okay, they are hashing algorithm. I'll tell you some more example of hashing. You will get more clarity about this hashing algorithm. So here the hash value of this size. The most commonly used hash algorithm is this one nowadays. Almost this is so powerful. There's no such bug. Not bug. I'm talking about the computing power that we have in till date. All the supercomputer, they can't break as such this algorithm. So there's no as such break available. Okay, so even though if you try to read this, okay, the number is so big to break this algorithm, okay, by some kind of attacks. So technically it's kind of breakable, but the computing power that we need, we don't have this computing power to find out two different text that give the same value. So they are collision resistance. Okay, and that is reason, guys, as I said, 2, 3 also come up with a more powerfulness, but very rarely I see version 3 has been used. But I think also there we have that we will have more more. There's no kind of a text plan also the way has been created. Okay, so but 2 is the one we use. Even though, guys, when I break, I capture the packet also today, I show you here also we're using SHA for something. For something we'll see in the next class. So in the Gmail, when login also, they also using SHA-256 for some hashing or some kind of or something. What is something we'll discuss more a little bit tomorrow and some part today also. Okay. So point is, guys, again, SHA is secure hashing algorithm. Till now, the most powerful version is 2. 3 is also there, the more powerful than 2, but the usable perspective that is there and implement the market is SHA-2. with 256 and multiple different hash value size. Even though one more example I want to talk about here is, if you guys ever use Linux operating system. Okay, so let me go to my Linux operating system very quickly. Okay, in the Linux, guys, we store the password. Okay, let me show you. So in the Linux system, guys, whenever you create an account as for user, let me create a user, let's say Harry. Then we normally set the password of the Harry with this command in Linux. Okay, I'm giving a password, for example, Q here. That's a normal password Q. Okay, but internally, this password is stored in my current Linux system. But my Linux system have no idea what is the actual password. Nobody knows the actual password. Only the one who set the password knows the password. Internally, my password is not stored in the clear text, and neither in encrypted cipher format. Okay, so anybody can know the key, they can break it. Okay, my password is stored in the hash value. And I'm trying to convince you till now here with the example of count algorithm. Whatever the hash concept is, either the count algorithm or mode algorithm or MD5 and SHA is so powerful. What are the techniques they use a lot? Okay, that is one way. You can't get it back. So password stored here, even though I know the password is Q single character, but internally the password is stored in hash value. And here they're using SHA version 2. So those who know a little bit about Linux, there's one file called shadow file. Okay, here this every user password stored. Okay, even though, guys, if anybody by chance stolen this file, okay, they won't get your password back. There's no tool and break or supercomputer available in the market that can give you a password back. Okay, so here the password Harry is stored in this format. This is the hash format. Okay, I'm just talking about the example of Linux system. Same we have in Windows, same we had other databases, some other hash value they're storing for the password. Okay, and if we a little bit elevate this string, okay, here this string has 3 different things they store in the Linux. Okay, first they stored here, if you see, guys, the dollar symbol, there's a $1 symbol, there's a second dollar symbol, there's a third dollar symbol we have. So dollar symbol is a separator of 3 things. Okay, first thing they store here is the name of the algorithm. Okay, long back that number was 1. Okay, if you use the Red Hat version 5 or 6 or 4, that number is 1. That means that time we were using MD5 algorithm. Here the number 6 is a number. The number represent we are using SHA version 2 over here. Okay, so in this file 6 represent, here in this OS we are using algorithm named SHA. Okay, so this is the first field. After this dollar, this big number, okay, is your hash value. Is the hash value. So whatever password is set, right? Internally a password never store, they only store the hash value. It is the same concept what I'm trying to explain you in my count example. Okay, here the hash value is stored. Count also hash value again one way. This is also one way. From this hash value, it is impossible to get back your real values. Okay, real values. But by chance, if you use count algorithm, 2 value might give the same hash. But here, because we use SHA is a collision resistance as such. According to computing power we have, so there's no way to find 2 different strings or 2 different texts and give the same value. Okay, if you find somehow, then what a password I said, you can log into my system with other password also, but that is not till now possible, and we have no break on it. Okay, only break that hackers are doing, that is not the bug or that is not the break. Technically, what break hackers are trying to do in this MD5 world or maybe SHA world, what they're doing, okay, for example, my password, let's say, is Red Hat. From the Red Hat, let's say I convert to 6. From 6 is impossible to get your data back. in the hashing algorithm like SHA, then this is so powerful. From here, the number is so big, getting it back is impossible. Okay, SHA or this kind of algorithms. Okay, so what hacker is doing to break this password that is converted into MD5 and SHA? Okay, what they're doing is, for extra knowledge, what they're doing is, okay, they know is one way, so they're creating a one big database. Okay, what they're doing, all the possible character, they're finding the hash. A hash is, let's say, 111, B hash is 222, C hash is 333, A hash is let's say 567, AB hash is 789. So AB, ACD, A12, A@1, Vimal, all the possible strings that is possible in this world, they're creating a very big database, and they keep on doing it because number of combination, if you see, of all the keyboard in your keyboard is so big. Okay, so hackers or the communities is creating this big database. Why? Because by creating this database, if somehow somebody get this hash value, okay, so they just put this hash value in their database, in their this database, and they compare with this values, like they search it, and whichever the match, they get your real values. Okay, so there's no DAG break, but this is how the communities or the hacking communities or cracking communities try to break the MD5. So it's not like pure break, but it's like all the possible combination they're trying. And if they find somebody has in their database in this kind of file, they put in this database, search it. Okay, they search these values. What are the find? It means because this has been already generated, they compare and they get the real answer. Or they get the real password, and after getting the real password, they log in the account. Okay, this database is called Rainbow Table. Rainbow Table they create. Okay, that is the reason, guys, in the market, lots of websites available for MD5 break. Mostly they write MD5 or SHA decrypt. Decrypt is not the right term, but they use here just to give everybody comfortable. This is a decryption. So they have this database. You see here, this website has these many 15 million trillion hash value already created, and they keep on generating. The program is keep on going on behind the scene to generating these levels of values in this Rainbow Table. Okay, so if you have any password that you want to break, if you have the hash value, you can put here to break it. Just for quick example, for example, I have one more tool to create the MD5, or maybe you can use OpenSSL, for example, to create the MD5. Maybe encrypt if they work here, or maybe directly I can put MD5, and though we have some command line option also. Let me use this command only, MD5, or let me give the password Red Hat. Okay, I do Control D, Control D, Control D 2 or 3 times. This hash value come up. Okay, from this hash value, it is impossible to convert a Red Hat. Okay, one way. But what hacking community done? They create all the possible combination of Red Hat and all the A, B, O, C, or I told you already, and they have all the hash value pre-generated or pre-created. Okay, so somehow if somebody know your hash value, if you don't know your hash value, and they put this kind of decryption tools, means they're talking about, reverse kind of things, what I try to tell you, and they decrypt. Okay, if they found this answers here, and hacker community believe they break the things, and we break them. They have same thing with they break the SSH also. But for me, it is not break. They're just generating Rainbow Table, and to get your actual answer back. So somebody get the hash value, they can put, and they get your password. And that is a reason, guys, because right now they are breaking. Now they're doing all the combination. That is a reason it is highly recommended, right? Whenever you set the password, give your password bigger in size. In such a combination that give a possibility that combination data they don't have in the database. For example, okay, If I give my password something like this, let's say VIM@123, 45 @QWERT. Let's say this is a password. I'm doing Control D, Control D, Control D 3 times here in the lines terminal. This has will come up. And this combination is so big. Possibility is in the random table they don't have till now reached to this kind of bigger combination because they keep on generating. Okay. Now, if I keep this number, same number, this number to this rainbow table or this kind of database is what they're claiming to break, but they can't break technically and decrypt. In this case, what you will find, okay, they're trying to see find out the database and finally no has found, right? So my point is what I'm trying to claim here is, okay, because I've worked a lot in security area and also delivered tons of different cyber security programs also. So normally I see in the market, hacking guys, they become very happy. They blame, claim also that we break the MD5 and SHA. It is not possible as such. Okay. They're only using a reportable and all the number that is pre-calculated, even though they're huge, like some billion trillions. But if you use the proper plan, it means your password policy is big, you have to use multiple characters, big character, then it won't be possible. That's what I'm trying to tell you. It is. Okay. So this is one thing. And that is a reason, okay, because normally if you say keep your password bigger, okay, so nobody keep this bigger password, they don't follow this policy. We know it. That is a reason, guys. What we do, if you give your password small, let's say Red Hat, okay, so what Red Hat is doing, or almost all the operators also doing, they combine this Red Hat with some random numbers, okay, and they create a new string. So Red Hat plus some random number, Red Hat plus some random number, they combine, and this is a new string come up, and this new string they will get hash. Okay, so this is the reason, guys, you can see one more part here, this number, this is a random number. So automatically in your operating system, maybe in database or operating system, they generate this random number for you, this random number. So what a password you set, for example, Red Hat, this number, this password you give, this number they randomly generate, they add together, is a new string. Again, they pass with the hash value and they give this like a string. So it means maybe this website, they have the Red Hat in their database of the hash value, but Red Hat plus this random number, okay, is a big combination, and that value won't be there in the database. Okay, so this hash value, nobody can get your actual password back. Okay, because by helping, by using this concept, and this random value, guys, is also known as salt. And this is use of the salt. Salt means mix something, add something on the real data, make your real data more bigger, more random, and give this value. Okay, even though same time, guys, same thing happen when you log in also. So technically, when you log into your system, okay, nobody know your real password on your mind. So let's say I put my password Red Hat when I log in to my login screen. So when I got a login screen come up, okay, login screen come up, and I got a login or username screen come up. I don't know why so for example, when any login screen come up, you type your password, let's say Red Hat. Again, your operating system go to this file, they take this, let me refresh this page first. They take this random string that is called salt from this file. Okay, salt from this file. Again, they add in the same way. What password you give from your mind plus this salt value, they add same way. Again, they use same algorithm like count or hash, SHA something. And I told you guys one property of hash is they always give the same value, same hash will generate. Sort of has generated on the real time when you log in, plus this hash they will compare when you next time log in, and they give the login with the hash match. Okay, so what I'm trying to tell you is everybody use different approach. Finally, hash algorithm we are using for authentication, either you directly store the hash as it is, somebody adds some sort to make this hash more complex or more random. Okay, there's a different point, but okay, hash is a one concept. Almost in every operating system we use, or databases also we use for storing the password and some kind of sensitive data. Okay, that the so no sensitive data means we're talking about those data that you think that you have in the mind. Okay, you don't want anybody know by looking at this data. So this kind of password is a good example for this. Okay, where we can store the data in the hash format. Okay, and by the way, guys, for your knowledge, it is not the part of this program, but it's just giving us a very quick knowledge. In Red Hat, especially Linux operating system, especially, you can why we using SSA version 2 or SSA 256 or 5112. So all the authentication part in Linux operating system is done by one concept of PAM. PAM is one very powerful security. Okay, they are the one who actually managing all the authentication part in your Linux operating system. Okay, there's one file called password here. There's one file pass wd here of the PAM, and if you see this in this file, okay, in this file, or maybe there's one more file called password file. Okay, password auth file. Okay, here we write for password we're using SSA 5112. Okay, so PAM is very powerful concept. Lots of things of authentication we can perform. Again, this is not part of cryptography access, but tons of things we can perform in the realm of authentication. So PAM is one topic where we cover all the things. It's a very powerful security module. As such, there is no PAM is so powerful everywhere we use it, but there's no training available in the market anywhere that cover everything about the PAM. I'm coming to a new program, especially only in the PAM, where I'm going to cover every concept of the PAM in very detail. Okay, soon guys will update you soon when I come to this program. Okay, but I'm just giving this information. So this is one point. So let's come back to our main point. Okay, in the cryptography, one of the use of the hash concept is to use for the authentication purpose. That's what I'm trying to explain you. The way they're managing behind the scenes is different. Either they store password directly, they're using MD5 and SHA-2 algorithm, or they're adding some extra salt that none of the rainbow table kind of attacks can possible, the way I show you the demo here. Okay, but authentication we use a lot hashing. Okay, but hashing is not only for authentication only. We can use hashing for integrity also. Okay, data integrity I'm talking about. What I mean by this. Okay, that's again very crucial concept. Okay, so let's say, okay, A want to send something to B. Okay, some data, again, say this is the CEO what I was talking about, and this is let's say my finance department. Okay, and A want to send that I want, this is my account number 111, I want $10,000 to be sent to me. So this document is sent to B. Okay, maybe this data is sent maybe in clear text due to some reason. Okay, clear text. So the possibility, obviously, any hacker can go and tamper this document before they reach to B. Okay, in this live packet also, guys, we have one tool available in the cyber security or hacking world. Live packet, we can stop on the fly and we can tamper this data on the real time. So when this data go via this line, the hacker can change this number to their account number, and maybe they can add more zeros in it. So when this reach to B, they feel this data coming from A, and they will send the data, account or money to the hacker's account. Okay, so in this case, let's focus about encryption. In this example, right, we can use the hashing to detect that somebody has tampered your data. How? Okay, when CEO is sending this information over here, okay, this document is a data. CEO will put this data into the hash function, and they come with some hash code or hash value. Let's say the hash value of this document may be ABC. ABC. And I told you guys, every data we have a different hash, unique hash. Okay, so CEO send this data to B, and by somehow CEO will update B that I'm sending the document to you, but my hash value is ABC, either over the call or some other medium, or maybe by SMS or by some other medium. They tell the B that my hash value is ABC. That's all. So when document reaches to you, okay, don't use the document as is. There's possibility somebody might tamper this data. When this document reach, again use the same hash algorithm, let's say SHA, to find the hash. Okay, and if you find the hash is different, for example, XYZ, and that is not matching what I send you or the code or by SMS or by call or some other medium, if they're not equal, it may somebody tamper it. Don't use this data. Ask me to re-forward, or ask, we might use some different channel to send you data back. But that is not the actual data we send to you. But if somebody is not change the data, it means exact data will reach to B. B use the same algorithm, same value gonna come up. If both the hash match, it means nobody has tampered it. If we are good to go, we can use this data. So whatever information A is sending, if same information reach to B, that's called integrity. That's called data integrity. Okay, and to checking the data integrity, okay, again we can use hash algorithm for this. And if you're using hashing for the checking data integrity, that concept is called checksum. We are checking the sum, okay, for the data integrity. So mostly, guys, in data integrity world, hashing is used a lot. That kind of demo I already showed to you. Let me show you one more time. Let's say we have this kind of file. Okay, file, let's say database. Okay, in this file, I'm putting my account number, my how much dollar I want to send in this account. Okay, and maybe I'm giving my name. This is a real document for my department. And this guy, okay, before they send the document, they can also find the hash of it. This is the one command we can use. Multiple command we have. And this document we can send some other medium. This hash we can send the other medium. Okay, when they reach to my final destination, we ask them before they reach this document or use this document, there's possibly somebody might tamper first and hash. If both the hash are right, same, when I send to you or a call, what you find, it may not be tampered. But if somehow somebody tampered this hash, maybe instead of this account, maybe little bit change the account number, maybe two small change you do here. The space also give. Okay, so your entire hash will be different. Last time my hash was, oh, whatever, I don't know, it's not there. Whatever hash I had that point in time is different. Right? For example, this is one, this one. Okay, last time in last 0A1C, but last one was, okay, is very different, right? It's completely changed. Even though it's given one extra space also, it's been completely changed. Okay, so in this example, this data integrity check, hashing is the most critical point we always use. Okay, so it means if you are sending SMSs, if you're sending email, even the email world is usually not right. Okay, somebody send an email to you. Mostly in corporate world, we always send the hash values. Okay, to check the things, what email actually we are sending, you're getting the exact mail or not. Especially, guys, in the software world, this very much useful. Okay, you know what happened, especially in the open source world, right? Somebody has created software. For example, somebody has created software called Firefox. It's open source, and now a lot of website guys has launch put the Firefox in their website. And when you start searching that I want to download the Firefox, Okay, multiple different sites come up. This side also come up. This side also come up. 100 more different sites gonna come up. And because this is the free software, or not free, I can say open source software. So there's possibility, because Firefox is a browser, possibility some hacker community might download Firefox browser. Okay, download Firefox browser, and in the code they might add some malware, some kind of extra code they inject. This like work like a keylogger maybe. Okay, they put in the Firefox, again compile it, and this share this, they start sharing this Firefox on the Google. If anybody want Firefox with some extra benefit, extra support, we can use our website to download the Firefox. And if you use the Firefox, their website, it will download, you can install it, work like an old Firefox, but behind the scene malware, some kind of worm, some kind of virus, or some kind of keylogger walk up, and every activity you do, they spy on it. Okay, that easy reason, any software that is belong to their respective companies, okay, they always give the checksum. In the some of the locations you find, guys, they say my checksum or my MD5 signature or my, where normally wherever you download, guys, it's not here, but wherever you download this software, while downloading in some of the area, they give you that if you're downloading software, okay, just try to find the checksum. So here's some links you find, and other websites also you can see. So wherever you download a software or maybe operating system, they give the checksum or the hash signature. And point is, after you download, okay, it is your duty, maybe manual or maybe have some kind of automated way, first find the checksum, okay, and compare the checksum in their official website. If they're both the same of that version, it means nobody has added some extra virus and malware. Or it's also helpful maybe while downloading on the internet, some packet might lose, some data might lose also. So you want to check that whatever data you downloaded is exactly same what has been there. So your code will work, your script will work the way it should work. Okay, so these are the lot of areas, guys. I'm just giving you multiple examples here, whichever maybe understandable or useful, you can understand that part very easily. Okay, so hashing, guys, is very much useful in data integrity. If somehow anybody change something, okay, we can come to know. And this is the core idea behind blockchain. So in the block, we have multiple block, okay, where we do putting a lot of transaction in the blockchain. Okay, if one of the block changed by somebody or been corrupted by somebody, their signature, not signature, I can talk about their data hash value change, and by changing the hash value, we can find something. Again, I'm not talking more about blockchain, but anybody know about it, that's what they might relate. Okay, why we need the hash there in the blockchain also. Okay, so two concepts of, guys, hashing I explained to you, authentication and the data integrity. Let's come back to a game. Okay, now based on this concept, now we can solve the issue what I was and we were facing in the game. Okay, the game that I was talking about, where is, okay, that can be solved. I don't know where I put my game. Come on. Yeah, here it is. Here is game. Now, based on, guys, concept, in this game we was having the issue of the last one always win. They use a trick. Okay. Now, how can we solve this challenge? Okay. Challenge is very simple. I mean, now we can use hashing to solve this challenge. Okay. Nobody can use a trick and a cheat here. How? Okay. For example, let's say Vimal again want to play last. Tom is playing initially. Last means Vimal is the one who revealed their value last. The point is, Vimal don't want to reveal their value, whatever value they have in the mind. Okay. Let's say, again, this is Tom and this is Vimal. And you want to play this game fairly. So Tom is the one who want to reveal the value first. But before they start the game, okay, we ask everybody to think their value in the mind. Don't reveal, think the value in mind. Let's say in the mind, Vimal say my value is 13. Okay, is there in the Vimal mind? He's not going to reveal because he's the last one. to reveal it. But we should don't reveal value, but do one thing, give the hash value of 13. That's all. Don't give me a real value, give me hash. Because we know the hash concept, guys. If you give the hash to me, okay, hash to me, nobody can revert it back. So technically, you're not revealing your value. You're only giving a hash value. For example, use MD5 or SHA tool to create your hash value. For example, let me very quickly do it. Okay, so let me use OpenSSL. Okay, I want to find, let's say, SHA2. If you have the command here, SHA2, enter. They don't have SHA2, they have SHA1 by chance, but I think they have one more command called digest. Is one command, OpenSSL digest, and here they have, I think, SHA. Okay, and let's say Vimal thing in my mind I have 30. Okay, so don't give me your real value, keep in the mind, but give me this hash value. From the hash value, nobody can get it back, the real value. One way is it is, okay, share this hash value to everyone. Okay, so that in the future you don't change your mind, you don't trick it. Okay, and now this time we ask Tom, now your first player, just share your value. Tom say my value is 20. Now Vimal say, Vimal, now your turn, your last, you share your value. Vimal say, I want to again trick, and let's say, because I know this is 20, I want to win, I need an even number, let me give 14. But now everybody can catch this. Okay, and say, Vimal, you say 14. Okay, let me find the hash value of 14. Control D, I write multiple times. This hash value come here, but you only share the hash value to us. It is not matching. It means you're not giving the right value. It means you trick it, you change it. So Vimal has to give the right value. That is 13. Okay. Actually, I entered multiple times. So I actually entered. This is what they come up, but let me run one more time. Even though the hash value is same in all the platform. Okay, even though you run hash in your Windows also, whichever operating system you use doesn't matter. Okay, hash is same in same algorithm is there in running OpenSSL DGHT SSA. Maybe this option might not be there, but if you use the hash in any of the operating system, anytime you call, you can get the same, right? So I think you got the idea. Okay, we might have to give the same value. Okay, and now this time this old, this time Tom will actually win with no is very with pure transparent game. I'm taking this example just to give you that context. Okay, whenever you have this kind of requirement come up, you want to reveal some information to, you don't want to reveal some information, but you have to tell them that this is the pure data integrity game. This is not going to change. I'm sharing your hashing value. Okay, so whenever you need the real answer, I can give to you. Okay, one of the example, maybe you want to publish a book. Okay, but right now you don't want to share the content to anyone, so you can reveal your hash value to some publishers. Okay, so after some year, you want to publish your content, your blog, your article, your research, research paper. Okay, if somebody copy by chance, you can take objection on it. As you say, I already revealed this document without revealing my document to real world. I reveal my hash value 10 years back or 20 years back, and this is this is an actual document. Just find the hash of it, you will get the answer, right? So multiple different examples and way you can think of the hash. Okay, and MD5 and especially SSA is the one of the powerful hash, and that's why multiple way to find the hash values. Okay, now one more challenge we have in the hash. Okay, and that can be solved very easily with one more last concept we had is MAC. Okay, one challenge of the hash sometime you might find is, okay, if you, again same example, you have one laptop called A, one more laptop called B. Okay, and A want to share the document, again the same example, CEO, this is the finance department, something like this. Okay, and they want to share the same thing, 1111, the account pass number, pass means amount is this one, this is an account number, and that's all. So this document is sending to B. Okay, but somebody might temper. Okay, might temper. What can you do? Okay, you can find the hash of it. Let's say hash of it maybe ABC. So ABC the hash code or hash value, or call my message digest ABC, and this is the actual text or actual message I can say. Okay, now A has to send this actual text to B. Okay, so this text, this guy can send via some network medium, okay, over the network, and this hash value A might send via SMS, other medium. Okay, but guys, if anything is very sensitive, then everybody has eye on it. Okay, so there may possibility some hacker, let's say example here is this is very sensitive and they are very smart. They have to keep an eye on every medium. Okay, when data is going through this network, what they do, this document again temper, right, and they change the account number to 2222, and this particular amount they might increase. This document is to B, and how B know this is the actual data without any integrity change. Okay, with the hash value. But hacker also have the eye on this SMS medium. They have some way we can also temper the SMS, or some other way we can also temper the SMS. And while the SMS is going on ABC, they change it by this medium, or maybe the other medium they're going, or some other way maybe. Okay, and what they do, what are the final data come up, right? Final document created by hacker. This hash value, let's say, it become XYZ. So they changed ABC XYZ. Okay, so finally B will get XYZ as a final hash, and this is the tempered document. But B is smart. Before they use the document, they first find the hash value of this document, and the hash value of the document B find again XYZ that is matched by XYZ. B thought that I'm the smart, and I check the hash they were used, they match, and they use it, and that's what the amount they transfer to the hacker's account. But they're not. Hackers are more smarter than these guys, maybe. So the point here is, okay, only relying on checking the data integrity from your real data with the hash value, okay, in your network setup or in this kind of setup is not at all secure. Okay, mostly here I'm taking the example of network or SMS, but in the real world, your hash and your data go to the same network or same internet or same Wi-Fi or same network channels. Okay, they're going to same channels. Okay, so it means tempering the hash or tempering the document, both can be very easily done by hackers and this kind of their tools. Okay, that is a reason, okay, for data integrity perspective. Okay, plus the authentication purpose perspective also, the way I explain you to the hash can be used for authentication purpose also. Okay, so what can we do to solve this problem? We can use two concepts together. Okay, so we can use message digest concept and the authentication concept together, and this become a MAC, message authentication code. Okay, what again, same idea, both the A and B initially share some secret keys or shared keys to each other. Okay, shared key to each other. So A has their own shared key. Let's say shared key would be let's say 1 2 3 4 5. Somehow they share the shared key to B, either by meeting physically initially, right, or sending the pen drive, or I show you the concept called PKI. Okay, that's the best way to share the shared key. Okay, that is very secure and powerful. In my asymmetric key concept, tomorrow I will explain this concept to you. Okay, but let's say some secure way, we share the shared key between A and B. Okay, now what they do, okay, this key they're not using for encryption purpose. Right now, I'm only talking about the data integrity purpose, right? So here in this document, whatever data you have, okay, in this data, somehow by some technique, they merge this key. I'm putting on the top here, but let's say somehow we merge this key in some binaries in some way. So it is harder to separate what is the key, and it is harder to separate which part is your actual data. Okay, so only the one who know the real key, they know which part is the key. So when this document reaches to B, okay, same document when they reach to B, this one, okay, this document, because B know the real key. So the algorithm we use to merge, let's called add this key in this document, almost same real algorithm in the reverse way. Okay, be used and say I know only this part. I can do some XOR or no or and some kind of binary operation to get rid of this key and get my document back. Something like this. So it is not like encryption. Okay, because by this way, okay, two things we can achieve. One, because both have the same key. So this document is coming from the right source. First of all, they were explained to you today about on authentication of symmetric key. Plus, okay, after you read off, they will get the actual document. And here in this document also, they are also sharing the hash key also. The same document we have your key, same document we have a data, and same document we hash values. Okay, because hacker now don't know which part is the key. The way we right now is looking very clear text, but in the what algorithm we use is very harder to pinpoint which part of is the key, which is the real value, which is the hash value. Okay, so for the hacker, if they temper anything, okay, temper any part, the hash value won't match, or key might change, or some data might not work. The hash there has been counted and calculated. Okay, so and the B, if they use the same key, if they temper, either the hacker might change somehow extended this key that is not workable, or I think you understand what I'm talking about, right? So MAC is a concept, right, through which we are maintaining the actual. This is actually helpful more about for the authentication purpose. Okay, we are maintaining the authentication part of it. Same time, they're also maintaining the integrity also of the document, but they are mainly for the authentication purpose, right? So MAC is a concept. Again, multiple different MAC algorithms we have. One of the two famous MAC algorithm, one of the most famous algorithm I can say is HMAC. Okay, is hash technique for message authentication code, right? So very quickly, if I tell to you, right? So HMAC is the one of the algorithm. Okay, it's for message authentication algorithm. So I told you there's three ways to do the authentication part. Okay, so HMAC is one of the way. Okay, one of the type of MAC, this concept I explained to you. Okay, where we have the crypto function and all the things. But that's very quickly I try to explain to you. Even though according to our plan and the content, we don't have to go in that much this direction, but I'm just giving this information that we use some shared key instant digital signature. What is digital signature? When I talk about asymmetric key, I'll talk about digital signature. So if you want to see the authenticity, we are some sharing the key between this, between these two parties, the way I explained to you inside the document. Okay, this is kind of diagram you see here. So in this diagram you see we have the key set, plus we have the padding, the data, plus our hash values. Everything is there in one document. They do some kind of XOR and some kind of operations behind it, so it's harder to understand which part is what. So anybody have the real key, then only they can get your real data back with the document or with the hash value. Okay, so typically it is used for mainly for authentication purpose. The data is been coming from the same source. Data integrity we achieve. That's what the true is, but it is also achieve authenticity also. So MAC is a concept that can achieve both the thing. Authenticity means we know it's only come from A because A is the one only that has the key. Hacker don't have the same key. Plus, it is also helping you in the data integrity also that normally your hashing will do. Okay, so it means whenever you need data integrity and the authenticity both together, okay, both together, then HMAC is the one of the great way to use. But otherwise, as a part of HMAC, we have multiple MAC algorithm available. Okay, for this concept for data integrity and the authenticity. Okay, multiple MAC we have. One of the MAC algorithm I told you is HMAC. Otherwise, we had GCM also. Okay, GCM also is the MAC algorithm, GCM. Okay, is a Galois counter mode algorithm. This one. Okay, and this is the exactly what Gmail is using. The way I started today, GCM. Okay, GCM is being used by Google. So it means this algorithm is using for authenticity also, and this is also using for data integrity also. Okay, this one. Even though guys, if you remember, this was the last page I show you in my last class, cipher mode operation. If you remember in my symmetric encryption, I just need 2 more minutes, then we can go to today's class. Okay, so this more guys explained in my last class, but here, okay, CBC I explained to you, but here in authentication encryption, okay, we have multiple authentication algorithm that I explained today and the integrity concepts. Okay, one of the name is GCM. So GCM is just internally using keys, symmetric keys. What do I need here? Both the side I need symmetric key. So this symmetric key is created by GCM. But if you're using the symmetric key for authentication purpose also, then it's become GMAC. Okay, means I'm doing authentication also from this key. So this key is symmetric key, but used for authentication purpose and with integrity also. Okay, data integrity also. But Galois counter GCM guys is almost the same what CTR is. You know what I explained CTR counter algorithm in my last class. ECB I explained to you. This other I explained to you. Counter I already explained to you. This counter. If I explained to you CTR. They are almost the same concept. This one. Okay. So guys, this is one concept. At least you know some idea what is happening behind the scene, right? We are going to very depth in this training, but so nowadays, guys, if you see in all the big PKI infrastructure, that was the topic, very important topic we are going to start tomorrow. That is the main part of this program. Okay, very interesting also. But mostly either you see HMAC or you see GCM a lot in almost everywhere. Okay, so finally now the conclusion is in 1 minute. Okay, conclusion is authentication is a different concept, I believe, understood. Okay, to claim who are you and to check who is claiming the source data is coming from that source only or not. Somebody sending SMS or mobile number, so they are the one who is really sending SMS coming from same source. Okay, authentication. Okay, one is encryption. Okay, means data is converted in different forms for cipher. Nobody can understand what data is. Data integrity. Okay, so in encryption, my data can not be understandable, but anybody can go and edit my data, right? Is a normal data, maybe binary format, they can edit, remove, do some changes. How we know somebody changes my data in encryption? So again, here the role of data integrity also comes in play. So after you encrypt the data, you can create a checksum, means hash, share to your destination. Okay, and before they use this data to decrypt this data, they can find the checksum. or MD5 sum or SHA sum. Okay, if they are matched, it means nobody change it, nobody temper it, data integrity is right. But if somebody edit this data, maybe they don't understand where they are editing, but they edit this data. So checksum will tell you that somebody has deleted the data, or maybe data might lost somewhere on the internet network. So data integrity is the one who do the thing for you. Okay, so that this is all the different concepts, and data integrity is done by hashing. Okay, hashing is never encryption decryption. This is a wrong concept. Okay, hashing is hashing only. Okay, and hash final output hash is hash value only or message digest. Okay, so that's all, guys. Lots of concepts we discussed.